Good morning. I'm Dr. Vishni. Today's class we are going to discuss about the transponders. So transponders is a series of interconnected units which performs a single communication channel between the receive and transmit antennas in a communication satellite. A bandwidth allocated for, let us consider different bands are allotted for the transmission. So here we shall consider the bandwidth that is allowed in the C-band service. So it is the bandwidth considered here is 500 megahertz, and this is divided into sub-bands, one transponder. A typical transponder bandwidth is 36 MHz and allowing for 4 MHz broadband between transponders. So in order to provide security and also to prevent the loss of the signals during transmission, we are using the broadband. So we are told such transponders can be accommodated in 500 MHz bandwidth. When making use of polarization isolation, these numbers can be doubled. So polarization isolation, which refers to the fact that carriers which may be on the same frequency but with opposite sense of polarization. So this is the frequency reuse planning. So here next is the frequency reuse planning. So which uses that is the horizontal polarization. Frequency reuse means the same set of frequencies can be used repeatedly. So within the in order to increase the number of frequencies availability of the frequencies, we can go for frequency reuse. The thing is the same frequency that can be repeatedly used at some other locations. Because of that, the collision of the or interference between the channels will be get reduced. So this frequency use also achieved with spot beam antennas. This may be combined with polarization to use to provide effective bandwidth of 2000 MHz. That is, first of all, the availability bandwidth is of 500 MHz only. So because of this frequency use, the bandwidth is available bandwidth is increased to 2000 MHz from the actual bandwidth. So that the transponder may handle one modulated carrier such as TV signal, or it may be handle a number of separate carriers simultaneously, each modulated by its own telephony or other baseband channel. So next is the transponder channels. So the figure which indicates the transponder channels. So here it consists of the receiving end, the signal will be received and it has a band pass filter and then it is passed through a wideband receiver. So here the input signal is demultiplexed. The wideband receiver receives the combination of number of frequency band signals. So that is divided. So here we have said that there are 12 available bandwidth channels are there. So that is divided into 12 channels according to their frequencies, and then given the power gain amplifier. So the gain of the signal is get boosted up and it is demultiplexed. So that is transmitted to the required users. So this is a wideband receiver. So the wideband receiver which consists of it's a duplicate receiver. The duplicate receiver is provided in if there are two receivers will be there. So one is the duplicate receiver. So in case the original receiver fails to operate, this duplicate receiver will be automatically switched on. So this combination is referred to as redundant receiver, meaning that although two are provided, only one will be used at the particular given time. The first stage in the receiver is the low noise amplifier. So this amplifier which amplifies the signal, the signal boosted up the signal strength. So next is the some number of noise will be added. So this also be added with the carrier signal. So the calculations involving noise, it can be more convenient to refer all the noise levels to the low noise amplifier input, so that the total receiver noise may be expressed in terms of its equal noise temperature. So the noise amplifier feeds into the mixer stage. Next of the noise amplifier is the mixer. So this mixer, which also requires a local oscillator for the frequency conversion process. So the power drive of local oscillator to the mixer input will be around, it can be of around 10 dB, Then the oscillator frequency must be highly stable, which have low phase noise. And the second amplifier follows the mixer stage. So here it provides the overall gain of this amplifier to the output of the second amplifier. The gain of the signal will be get boosted up to 60 dB. So the baseband receiver which utilizes only solid state devices, so which will tune to the signals to be operated in the transponders beside that is of around 6 bar 4. So next is the input demultiplexer. So the input demultiplexer separates the incoming signals that will be divided in number of frequency channels. So here the frequency ranges is from 3.7 to 4.2 gigahertz, and it provides the frequency separation. So first of all, the received signal will be received by the receiver and it is given to the 3D coupler. So next, the signal is passed through the signal at the end when it is given to the filters. So each filters which has different frequency bands. So once the signal is passed through the filter, the record signal is separated. So by which the incoming single signal is divided into multiple channels. So related levels in a transponder. The transponder which consists of a number of components, that is the input filter, wideband receiver, 3dB coupler, demultiplexer, attenuator, power amplifier as well as multiplexers. So this is the level of the transponder. First of all, the received signal that will be given to input filter. So the filter removes the noise component added in the transmission path, and it is passed to the wideband receiver. So the wideband receiver which receives the signal, and it is given to the 3dB coupler. So the next is signal is given to the demultiplexers, which consist of number of filters, and accordingly the signal will be separated and it is transmitted through the corresponding channels. And to boost the signal strength, we are using the power amplifiers. The signal is boosted up and it is given to the multiplexer. So finally all the signals will be multiplexed and that will be transmitted as a single channel. So thus the signal will be communicated from the earth station to the satellite as well as satellite to the earth station. Thank you.